welcome to the week 6 assignment of artificial intelligence search methods for problem solving. So group 1, in the given map, which of the following heuristic function satisfies the monotone condition? The answer is Euclidean distance. Coming to the group 2, the same graph once again they had given to us and asked us to calculate the follow the algorithm, that is WA star with the W is equal to 2. Okay, so while coming to the WA star algorithm, both if you see whatever we saw in the A star algorithm, the same thing we have to follow. So for A star, what we have done, for A star, f of n is equal to g of n plus h of n, where g of n is the distance from the node to the starting node to the node n, and h of n is the distance from the node n to the goal node. Now while coming to the WA star algorithm, that evaluation function f of n becomes g of n plus 2 into h of n, that is w into h of n. So in now they had given w is equal to 2. So now our evaluation function is equal to g of n plus 2 into h of n. So whatever the w value, we need to write w into h of n. Okay, now if you follow the algorithm, now we are having this is the open list and closed list we are having. So first this is the open list, so more is the closed list. So now right now connected to S. So I, C, K and A, A, C, I, K, A, C, K, I. Okay, so first we are writing G of n plus 2 into h of n. So G of n means from the starting node to the node, means S to A, S to C, S to I and S to A. So S to A is 40 plus 2 into h of n is the heuristic value. So whatever we followed in the previous weeks, that is 2 into, so whatever the h of n, that is 200. So we will get this as 440. For C, the distance is S to C is 80, 80 plus 2 into h of n value for C is 170. So we will get this as 420. And the K, this is 50 plus 2 into h of n is 150. So we will get it as 350. For I, S to I is 60. So 60 plus 2 into, for I, h of n value is 120. So we will get this as 300. So among this one, we need to select which is having the lowest value. So I is having the lowest value. So I parent is yes. So yes is the parent node. Okay. Now we need to write the nodes as it is in the open list. A with 440 and C with 420, K with 350. Now expand the node I. So whenever we expand the node I, the nodes connected to I are M, H, L and C. Okay, M, L, H and C. So whenever we are writing G of n for M, so we are reaching from S to I and I to M. Now this is your G of n value. S to I to M. 60 plus 50. So we'll get it as 110 plus 2 into h of n value for M is equal to 80. So we'll get this as 270. Similarly for L, 105, that is S to I to L. 105 plus 2 into 110. So we'll get this as 325. Next for H, similarly S to I and I to H. So 140 plus 2 into 100. So we'll get it as 340. Now for C, again S to I and I to C. So S to I to C 120 plus 3 into 170. So we'll get it as greater than 420. So neglect this one. Okay. So now which is having the minimum value among this one? M is having the minimum value. Now move M to the closed list. So open and close list. Now we are moving M to the closed list. Parent of M is equal to I. So what are the nodes we are having in open list? A, C, K, A, C, K, A with 440, C with 420, K with 350, and L, H. L with 325 and H is having 340. Okay. Now we have to expand the node M. We are not having any node connected to M. So the next node is L. Parent of L is I only. So whenever we are expanding I only, we got L. Now we are having A, C, K, A with 440, C with 420, K with 350, and H we are having 340. Now expand the node L. So whenever you expand the node L, we'll get O, Q, I, and K. Already and IK will have greater G of N. That is S to I to L, and again from L to A will get the more value. So we are neglecting I and K. Now we'll write O and Q. Okay. So O and Q. O is having, that is S to I to L, L to O. We will get this as 155 G of N plus 2 into H of N value is 90. So we'll get this as 335, and Q value is 185 plus 2 into 40. So we'll get it as 265. So if you want to write again K value which is connected to this K value, what we need to write is to I to L, and L to K. So it is 60 plus 45 plus 60. Previously it is K is 50 only. Now it is greater. Okay. So we are neglecting that one. Okay. Now see which is the node having the lowest value. Q is having the lowest value. So move Q to the closed list. Closed and open Q. The parent is L. Now we are having A, C, K, H, O. Okay. A with 440, C with 420, 350, 340, O with 335. Now we need to expand the node Q. Q is connected to again N, R, and Z, and O is also there, but the distance is high, so we are neglecting. So N, R, Z we are writing. Okay. So N, R, and Z. So the N is we are having 225. This is to Q. After reaching Q, Q to N. So previously we are having Q is 185, and 185 plus M 40. Okay. So we'll get 225 plus 2 into 50. So we'll get it as 325. Again R is also same, 225 plus 2 into 50. We'll get it as 325. And for Z, 235 will get Q to Z. Previously Q is 185 plus Z, Q to Z. Q to Z is 50. Okay. So we'll get 235 plus 2 into 40. So we'll get it as 315. So which is having the minimum? G is having the minimum. Now move G. Parent to G is Q. Okay. So now we reached our goal node. Stop here. So write in the reverse way. G to Q, Q to L, and the L is having the parent I. I parent is S. Okay. Yes. So the path is S, I, L, Q, and Z. So the path cost is S to I. So whatever the values we are having from S to I. Okay. So S to I is 60. I to L is 45. L to Q is 80 plus 50. Okay. So that is the path cost. So they asked us to write the third, fourth, and fifth nodes. So First is the S, next I, next M, L, Q. So we have to write the second, third and so first third one is MLQ. Okay, so MLQ, the F values are for M value is 270, for L 325, for Q 265. 270, 325, 65. The path is SILQG. SILQG. And the path cost is 235. Okay. Thank you.